Alright, welcome back. So today we have the second K7400 that I talked about in the previous video, where the previous video with the HOT going out and the bad R823. This one is the sister chassis to that one for the same person, and this one is not powering on, it's dead. So we have a power supply problem. And first of all, before we go any further, we need to check and make sure all of our potentiometers are good. None of them appear to be broken, so that's okay. Nothing seems amiss about the remote board, so we can disconnect that and get it out of our way so we are not encumbered by it. And the neck board here, as is typical, all of our resistors here are smashed flat, which, you know, I don't think I've ever received one of these that didn't have the resistors smashed flat, because they don't get protected properly. So we will rescue those. Alright, and then we have our transistors are a bit out of alignment, and I'm worried to move them around because I don't want to break the pads on the back, but that seems to be okay. And then our transistors here are touching the heat sinks. We don't want that, because they'll induce heat from the heat sinks onto the transistors. So, alright, so that seems okay. Let's put all of our pots in the center like we always do. Get a good baseline for color. Now the K7400 has is the only one to have a sub-contrast pot. There's a pot right here that's sub-contrast, and you can adjust. That was almost all the way up. You can adjust your color based off of the sub-contrast as well. But the 7400 is the only one to have this. The U5000, 2000, and 7500 don't have that. So just kind of be aware if you want to adjust, or you can't get enough from your colors, or can't get enough from your standard contrast pot on the remote board, you can always try the sub-contrast pot. Alright, and the neck board seems okay. We have another low hour one, because there's some heat here, you can see some heat, but not too bad. The pads are in good shape, solder joints are in good shape. I think the previous person reflowed all this when they did their cap kit. They did a cap kit, but they did not change out the bipolar cap, so I'm going to change that out too. Not that it needs to be changed out, but they did an entire cap kit, but they did not change out the bipolar, the 50 volt 10 microfarad bipolar cap. So you can see that they've done a cap kit on this. These caps have been replaced. You know, for instance, you see the glue is different here and glue is different there. There's no glue on this one. So they did a cap kit, absolutely, but they did not do all of them. They did not change out what looks like this cap here doesn't appear to have been replaced. This bipolar cap was definitely not replaced. So not all of them got changed out, but not critical. We'll see what we can figure out, but I'll change that later. That's not going to keep it from powering on. So with the neck board being okay visually, let's disconnect it and get it out of our way, so we're not flopping it all around while we're doing our testing. Okay, it's out. Alright, so we got a chassis here that is reported as not powering up, and there is no switch mode power supply chip installed. You can see here that it has been removed and socketed. So I just happen to have a known good one that I removed from a donor chassis. So I'm going to put this in here and we'll do some testing. And the socket is incorrectly. The socket is installed correctly. I don't want to put this in backwards for sure. Alright, so we've got a known good one installed. And yeah, the reason this was removed was because, you know, it's not powering up and it's dead. So usually when that happens, we got a switch mode power supply chip problem, and the original owner removed it and replaced it with new ones, but the new ones were bad from stock. The new ones that were replacing the old one were bad, so they didn't have any good ones for reference, and so I just happen to have some good ones. So I put this as a known good one. And I do want to mention here now that I look closely is that like a lot of these, the linearity coil is broken. Well, the coil itself isn't broken, but the magnet is loose on here, and it's broken off of the cardboard holder here. So we're going to have to secure that back in place. This is another casualty of shipping being bounced around. So it'll be okay to leave it like this for now, but we're going to have to fix that before we ship it back. Okay, so let's do some testing, because a lot of times if you have a switch mode power supply chip that's getting taken out, you can have one of these two capacitors are either open or broken. I had one of these before where there was some corrosion under here, and one of the legs for this capacitor, could have been this one I think, was actually corroded completely off, and this was only being held in by one leg. So we had a bad capacitor that was causing a switch mode power supply chip to not function properly. And you know, it very well could be. We can do some testing. If we don't find anything, we'll do our light bulb test and see what happens, because maybe it just, for some reason, the switch mode power supply chip decided to die and it just needed a new one. That's all it needs. Sometimes a component fails, and for no reason, just other than it's reached its lifetime and decides to fail, and put a new one in and go about your business. So it could be just the chip went bad, put a new one in, and it could be fine. But let's do some testing here real quick. Let's make sure our chip reads what it's supposed to. Yeah, there's evidence of cappage here, so let's go to our diode checker. And let's go, okay, we don't have any pins touching each other. Good job on the installation of the socket. So here to here should be diode voltage drop. And we get, there we go, there's our voltage drop. And if we swap our leads and go to this middle pin here and the outside pin, there's our voltage drop. And we should have, I think, roughly 1.7 on this one. 1.8, that's good. And roughly 1.5, I think, on these two. Yeah. So that's a good reading. So our chip should be good. Let's test our, well, you know, if we had anything wrong, in this section, I don't think I would read the correct readings. Like let's say if I mentioned before, if one of these two capacitors or even this polycap, if any of these caps here around the chip were bad, it shouldn't read properly. But we can test those caps real quick just to make sure that they're not shorted or open. So one of them is here. So that's good. This one, here's the other one. I think that's what that is. Yeah, yeah. One of them is here. And the other one is here. It's odd though, this one's reading 650 while this one reads in the megohm. I don't know if that's correct. And then our polycap, the polycap is this one. See, you would expect the cap to read open across there, but see, that's 5K. Let's grab this U101 I have here that is normally on the tube that I'm using for testing these things. And let's test this one. Actually, I can't. This one's a different setup. Let's grab the K7400 that I just fixed in the previous video. Since we know this one's working, let's test this one. Alright, so we go to the same capacitor here. We're getting a negative megohm, but it's reading megohms like the other one. This one was what, 500 ohms or something? 647. Okay, so that's correct. So those are that's a normal reading apparently. So those caps shouldn't be the problem. I didn't think that they would be, because like I say, if you've got anything really wrong in that area, your switch mode power supply chip's not going to read properly. Okay, let's test our R104 10K. Yep, 10K. These can read anywhere between 9.5 and like 13K, and they'll still operate, or it'll still work the way it's supposed to. So yeah, and I mean, like I've said before, if you test this and you read your 10K, that usually indicates that there's not anything wrong here. If this reads some kind of weird reading, either this is out of tolerance or there's something else influencing it. But almost, I'd say 9 out of 10 times, or 9.5 out of 10 times, if this reads 10K, then you've got everything in your power supply section should be okay. So I just wonder here if we just don't throw a light bulb on it and see if we get it to work. Because I don't want to spend an hour going through and testing this resistor and this resistor and this inductor and that inductor and this diode and that diode and this diode and this film cap and that film cap and this inductor and so on and so forth. I think with the fact that this is a known good switch mode power supply chip and that it's the fact that it's reading properly in circuit, I'm tempted to just throw a light bulb on here and see if I can get this to work. So I think that's what we'll do. I will get, let's zoom out here. Let me get my power connector. Plug it in, plug it in. Let's get our... Oh, first I have to remove the L100 here. Let's grab that and take it out. I think it's here. Yep. L100 is now out. Let's clip this on here. And we'll have to do another one. So this black lead will have to go to our B+. Alright, so that's hooked up. And then we'll have to use our negative lead. Now I need one more jumper. Here we go. To go to ground for my negative lead here. Just to hold it in place is all it's really going to do. Alright, so now we just need our light bulb and to touch our frame. Bubble wrap again, and let's see what we get. So let's turn it on. 172 volts, okay. Well, here we go. Does it work? Oh, get the right one. Does it work? It does indeed. 123. That's a bit high for our B+. But look, it works. So it looks like all it needed was a good switch mode power supply chip. This makes me, like I say, this is not a big enough load on the circuit. So 124 is probably okay, because once we actually hook this back up in circuit and run it on a picture tube, it'll probably be right at 117. But we can see it's operational. So this was reported to me as being totally dead. And I think maybe it was just the switch mode power supply chip went out, as I say, as things do. And all it needed was a good one. So the person that owns these told me that he bought some stock, and the ones he got were no good. So I put a known good one in, and hey, it fires right up. Well, so far anyway. So I think all it needed was a good replacement chip. So yeah, if you ever get one of these that's totally completely dead, make sure Q703 is good, which in this case I assume it was, because we can check it. now that we know our power supply section is good, we can check Q703. If that's good, then I'm going to put this on a tube just the way it is and see what happens. So yeah, let's discharge our B plus here. Let's just touch our frame, and that zapped it right down to 0. So we're now discharged. We can put the L100 back in, and I think our B plus will be set properly. We can test to make sure our shutdown pod is set to 4.5K or so. We'll check Q703. If all that's good, we'll get it on a tube and cross our fingers. So yeah, let's see. Get all this out of the way. Put that there. Put this here. Set our bulb out of the way. It's all this. Disconnect power. Okay, let's start with Q703. I gotta get rid of our plastic piece here. It should be 0.6 voltage drop to 0.6 voltage drop to this pin here from the middle. Other one should be 1.0, give or take. Let's switch hands here. Oh, see, that's another... Is our HOT good? No! Huh! Well, I'm glad I tested that. Another HOT going out. Well, that's why we get 0.6 voltage drop on each side of Q703, just like last time. Well, here we go. That's I'm glad I tested that. We would have found it when it started ticking. Let me get my fan on here. We don't have another bad 823, do we? Now that I think about it, yeah, put that there. 823. Nope, that's good. 2.2, 1.7. Yeah. C121, is that good? We're just checking to make sure that this isn't shorted. Nope, open. That's good. Well, yeah, and this has the more robust FJL series in it, like I put in the last one. Interesting. Well, I think what we'll do is, I guess we'll do some more testing here. Let's take the HOT out, and then we'll retest Q703, and if it reads properly with the HOT out, we'll put a new one in. If it still reads properly with the HOT, with a new HOT in there, the way it's supposed to, then I think we'll go ahead and just turn it on and see what we get. And my iron here decided to go back down to 0, or to 360 actually, because after it's on for a while and doesn't get used, it defaults back down to 360, so it kind of saves it on power and doesn't burn itself out. So bear with me here just momentarily. I'm too stupid to learn how to fast forward stuff. I've got a handful of, let's see, 1, 2, I got 5 of these FJL ones. So I can afford to burn through one if I need to. Okay, here we go. But theoretically, a switch mode power supply chip being bad should not take out the HOT. So I'm somewhat hesitant to put a new one in here and turn it on, but for the sake of, well, let's see, for the sake of what? For the sake of entertainment, I think that's what we'll do. But I'll test a couple of other items first. Because if these FJL series HOTs go out, you've really got something wrong. All right. Okay. And that's out. So let's test it out of circuit. Yep, it's gone. Okay. Now with that out of circuit, let's test Q703 again. And we got voltage drop and 1.0. Yep, 1.1. So we are good for that aspect. Are the pads for the HOT shorted? Nope. So yeah, that's quite interesting. So let's test our shutdown pot and make sure it's around 4.5. 4.5K. I think it's this one. Yeah, hey, 4.583. So our shutdown pot is good. Our B plus should be okay, because like I say, at 123 with that light bulb not having, I think it's, what wattage is this? 35 watts? 23 watts. So if we had like 100, I should be using a 100 watt bulb, I think. But because it's not not a big enough load on the system to bring it down to what it should be, it's probably going to be closer to 117 when we actually hook it up to a tube and have it function. But it does take a lot. Well, this is all loose again here. Yeah. It does take a lot to short out these beefier FJL series HOTs. So something was really wrong. Now it could have been an issue with the power supply, but we know that C121 is good, and we know that our Q703 is good. So I'm going to change out this bipolar cap here. Maybe there's something wrong with that. Not very likely, but a possibility. And now that I think about it, let's go ahead and get L100 back in here before I forget. There we go. Alright, let's get this bipolar cap out of here. There you go. And believe it or not, the replacement is about 5 times smaller than what's needed. Where are you at? Where are you at? Where are you at? I know you're in here. There you go. See, look how much smaller this size is in the comparison. So if you zoom in here, you can see 50 volt, 10 microfarad bipolar. 50 volt, 10 microfarad bipolar. So it's quite the difference. But that's absolutely normal. This is what's included in these kits. So let's zoom back out. And I gotta clean all this Like I said in the last video, I should be more organized, but I'm not because I'm just too lazy. So like I say, I don't think that bipolar cap is the cause of our problem, but it should have been replaced with the rest of them, because I have seen that particular cap in, well, I've seen that cap in particular bulge before. So let's get this one in here. And polarity isn't specific, but I mean, if you look here, you can kind of see it may have been leaking. See how it's shiny there around here? It may have been leaking a bit. Interesting. But polarity isn't specific on the bipolar, of course, but the black is negative, short leg is negative, so we'll put the short leg in the negative. And yeah, it's a much smaller footprint. Times change, you know, so there you go. Oops, sorry. Okay, so that is in. And let's do a couple more quick tests here before we. Oop, I forgot to put that one back. We'll do a couple more quick tests here just to see if we can find anything else out of the norm that might explain this. Okay. We can do 801, Q801, this guy here. If this guy's bad, it can cause an HOT to go out. So we'll test that. This guy here. $11K. I don't think that's right. $11K? Huh. I don't know which one of these is base and collector, so let's go there. Oh, I'm a moron. I was on ohms. Okay. Not the diode checker. Okay, so that's open. There's our 0.7. So I think actually 0.6 and 1. Okay, one of these is going to be the base. There we go. Okay, yeah, it's good. I mean, it's not shorted and it's not open, so that's all we're worried about. So I don't think Q803, 801, 801. I don't think Q801 is the problem. We've changed our bipolar cap. We know C121 is good. L100's back in. Q703 is good. Assuming that, well, R823 we tested, so we know that's not the problem like it was on the last one. So we can test our poly caps here and make sure it's not a poly cap problem. Make sure none of those are shorted. But they shouldn't be because our HOT pads weren't shorted. Usually if the HOT pads are still shorted, it's one of the poly caps. But we can test this one. Good. That one. Good. And I think the other one was here. That's good as well. So our poly caps are good. Well, I'm going to put an HOT in it and I'm going to turn it on. And we'll see what happens. Out of curiosity though, I want to see if something else here. Yeah. 1.4, 1.9, 17K. .4, 1.3. That's a different resistor. Now my curiosity's peaked. Hang on. 1.5. 1.5, 1.2, 1.6, 18K, 18K. Okay, yeah, I just wanted to make sure. All right. Well, okay. HOT time, and let's fire it up. Okay, doesn't need to be super tight, just snug. Okay. Gotta fix our linearity again here. I may just toss some super glue on there for now. I'm not going to put a whole bunch of solder on here in case I have to take it out again. But that should be okay. Alrighty. Yeah, seems okay. Let's test it one more time. Make sure our Q703 still reads okay. Voltage drop and 0.9. Yeah, that's what we read. That's what we read on the last one after putting this one in there. 0.5 and 0.5. Okay. Well, hopefully we get lucky. If we don't, we'll try and figure out what the problem is. But we already know our power supply is good. We know our Q801 is good. We know our 823 is good, our 823. Our polycaps seem to be okay. So there's really not much else. I think sometimes the LA7850 can cause issues with power problems and HOT issues. So we may want to take a look at that. I can go ahead and look at it now. Let's make sure there's nothing shorted on it. That's all I'm interested in. Okay, so we've got our ground plane here. Okay, let's just make sure there's nothing shorted here. That's the ground. Okay, nothing shorted. All right. Well, here we go. On the tube it goes. Cross our fingers. Okay, all hooked up, ready to go. We got anode, neck, yoke, ground, video, power, and remote board. We're set up to read our B+, and hopefully we get as lucky as we did the last time. I'm 50-50. But if it fires up and holds steady, yeah, I think we can call it a success. But it's too early to tell. So nothing to it but to do it. 1, 2, 3. Let's see what happens. Look at that. 117.8, holding steady. And oh, I forgot to turn the light off here. Uh-oh. Uh-oh. We got issues. Major issues here. Yikes. Well, it's working. It's operating. We're holding steady at 117. And we've got major video problems. That's not good. Well, we can figure that out. That's not a problem. Well, I say that because it should be very simple. You've got this chip here, and you've got this chip here. So it's really going to be only one of two things there, unless there's something else way wonky or way wacky. But yeah, that's... Hey, at least it's up and running now. We don't have collapse, so we got to figure out what in tarnation is going on here. Let's turn down contrast. Oh, hot dog! Look at that! I just turned contrast down. I don't understand what's going on there, but if we turn our contrast down, bada bing. Right now, contrast is absolutely 0. Brightness 0. Contrast 0. Oh, we still got some kind of issue here. Huh. Well, let's turn down that subcontrast, because that was turned down originally. Let's turn that subcontrast pod down. See if our issue with that goes away. Well, too late now. Okay, subcontrast is all the way back down where it was before, and we're still too bright. So let's turn our screen pot back down. And, okay, roughly there. Alright, now let's turn up our contrast again. Oh, see, nope, we got issues. Yep, look at that. So something on the contrast circuit is causing that. It's got to be either this chip, or this chip. But I think this is more for your, because we had a problem. I had a problem before where it was shaking. The image would jitter, and it was a bad capacitor here next to this. And I'm wondering if maybe we have an issue with that chip or this chip. Interesting. Well, let me do some poking around. If I turn the contrast down, you can see that it gets good. There. I also wonder if we have a neckboard problem. If I turn up the subcontrast, what does that do? Does it cause the same problem? It does. Well, that's a problem I've never encountered before. Yeah, the brightness needs to stay about there. So our flyback is set and our brightness is set, but we have a dark image. If I try and turn the contrast up, it does this. Huh. I've never seen that before. Well, I think I'm going to swap. You can see here it starts to, I'm going to swap neck boards just to rule out the neck board, because I can't, I'm skeptical of that as well. I doubt that that's what that is, but I'm going to swap that out. If not, I'm going to start probing around and seeing if I can find an issue around either one of these two chips, maybe in the contrast circuit, because it could be anything in this area with the affecting the contrast. But at least we have no more shorted HOT, and we have a good working power supply section, and we're good around, well, it's 118, but like I said before, it changes depending on what's on the screen. It changes, but 118 is fine. So I think we've solved our original problem of being dead by putting a known good switch mode power supply chip in there. So that fixed that problem. A new HOT solved whatever was the reason why it was shorted. I don't know. But now we got to figure out what's going on with our contrast. Wiki, 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 wow, wiki, wiki, wow. Sorry. Okay, well, let's power it down. I'll do some probing and see what I can figure out. Alright, so thinking that it was something with the neck board, I actually took the neck board from the other chassis, that I fixed in the previous video and slaved it onto this chassis that I'm working on now, and the problem was gone. Contrast works perfectly. So right then and there I knew that there had to be something wrong with this neck board. And this main chip here, the U500, is what processes all the coloring and sends it off throughout to the neck. Basically it's the RGB decoder and things like that. So looking at this chip, I was looking at the components around this chip, and I want to see if maybe you could spot the problem. So let's look at this chip here and see if maybe you can spot what the problem is and the components around it. I'll give you a few moments here. This is a factory. This is factory mod. This is factory mod. This is factory mod. So don't worry about anything over there. Let's keep looking here. Do you see it yet? Anything? Do you see what the problem is? Well, I'll show you what the problem is. This guy right here is broken. That is a broken capacitor. So I don't know when, how, or why, but this one here smashed over flat as well. So we can actually kind of try and bend him up out of the way. And I use the word try there appropriately. Why is it like that? There we go. Okay, so that's kind of not as bent, but anyway, we can kind of leave that like that. But there's our problem. I'm absolutely, completely, 100% positive that this is our issue. So I'm going to replace that with one from a donor neck board. As we can see here, I got this neck board here that I robbed parts from. This was a neck board that came with this U5000 that was destroyed in shipping. I bought two of these U5000s in untested condition, and they both arrived with the boards snapped in half because the side of the shipping box had been ran over by a steamroller. And just showed up on my door that way. So, I mean, I think I paid $100 for both of them in untested condition, so it wasn't worth me trying to make a big deal over. So I figured, hey, I'll just use them for parts, and that's what I do. So I got two of these like this that are snapped in half. And I'm using the parts from the neck boards for stuff like this exact purpose. So I'm going to steal, well, you know, it turns out actually that if we look at this board, that same capacitor in that same position is electrolytic. C512, it's electrolytic on this one. On this one, it is, zoom, focus, it is not electrolytic. It's a polycap. So I'm going to take this out of here and put the electrolytic in place. And I'll bet you dollars to donuts that our problem is fixed. So let's go out here and remove the supports. Okay, there's that piece. And a witch! We have found a witch. May we burn her? How do you know she's a witch? Well, she looks like one. Yeah, she looks like one. Send her forward. I am not a witch. I am not a witch. But you are dressed as one. They dressed me up like this. No, we didn't. And this isn't my nose. It's a false one. Well, we did do the nose. The nose and the hat. But she's a witch. What makes you think she is a witch? Well, she turned me into a newt. A newt? I got better. Burn her anyway! Okay, so let's put this back in here. Oh, you bastard. I didn't hear it fall out. By the way, this is a 50 volt, 1 microfarad. Alright, stay in place there now. Okay. Now I think we should be good. So let's get this back all together on a tube and see if it works this time. Okay, all hooked back up, and as you can see here, we have our new cap installed, the 50 volt 1 microfarad we stole from the other neck board. And it'll be absolutely fine putting electrolytic in place of a poly, no issues there. So we're all hooked up, ready to go. Oh, we're not hooked up and ready to go. I got overzealous here. Let's do power and video. See what happens when you don't count to 7? Anode, neck, yoke, ground, video, power, and remote. Every time you don't count, you forget something. That's why it's important. Now we're ready, and contrast is all the way down, so... Oh! Turn my light off so we can see. There you go. And let's turn it on. 1, 2, 3. Okay, we get power. And... I don't think we'll have an image because contrast is all the way down. We might though. Nope, we don't. Oh, we do. Just like before. I guess it just takes a while to warm up. So there we have it. What happens if I turn up contrast? Hallelujah! Well, it bleeds because we have our color pots in the center, not down a bit. But look at that. All the way down. Turn it up. There we go. That was our fix. How about it? So now let's see if we can adjust screen size and everything. Doo-doo-doo. All right. Let's do... missing some of the adjustment knobs here, unfortunately. We can pop them out and put them in the other ones. So it looks like we need to move vertical position. Let's do... our brightness here. There we go. Brightness needs to stay about right there. And that's not bad. Look at that. Pretty good. Colors aren't quite perfect, but like I say every time, it's not staying on this tube, so it doesn't matter about colors. That's why I put them all in the center, just to get a decent baseline to make sure we have good RGB. So let's adjust our... I gotta pop out these caps here. I can't. Well, I'll tell you what, hang on, let me grab another one of these and pop some caps out, put them in here temporarily so I can adjust this one. Hang on a second. Well, I only ended up having one extra one. I don't need one for the vertical hold, but I had a spare board here. I had one extra adjustment cap, so I put that in the vertical position. So now we can do this here. So we need to equidistance ourselves from top to bottom. All right, so vertical position works. Height works. Let's see, H position works, and it tries to fold over on itself, so let's go right there. Let's do our width. We have we got width control. I need another screen to pop up here to make sure we can position it. Our contrast is too high. If we turn it down a bit, there we go. H position needs to move to the right. That would be this one. So right there's about equidistant on both. Well, gosh darn it. But yeah, we got as you can see, we got a full screen, and we got good RGB. All the controls function, and it's running. So I think we're good. Another one successfully brought back to life. So two K7400s here, back to back. Got them both up and running. This particular one had a shorted HOT. I don't know why, because it's working fine with the replacement. It could have been the filter, this B+. It could have been this bipolar cap. Could have been this bipolar cap. I don't know. I don't think so. There was. I mean, it looks kind of discolored here on the bottom. I can't say, but yeah. I mean, putting a new one in works just fine. So we had a shorted HOT, can't say why. We had a bipolar cap that should have been changed out. We had a broken C512 on the neck board that was causing contrast problems. And we had a bad switch mode power supply chip that was keeping the board from powering up, and after putting a new one in, fixed that. So yeah, I'll let this run for a couple of hours, assuming it'll be okay. And that'll be 2 in a row here on these 7400s. So Yeah, hopefully you learned something. I know I did. Never seen that happen before. Never seen that particular problem that we're having. So thanks for watching. Like, share, and subscribe if you want. And we'll see you on the next series of repairs. Or the next individual repair. Who knows? Got lots to do.